Okay, so as part of my topic portfolio, I'm making this 3-minute video along with Killian is in the video with me, and I'm just going to try and explain my rationale behind my resource development and my assessment to a student to further emphasize the importance of why I went about doing it this way. So for my resource development, I made a 3D printed models in order to alleviate possible difficulties with the visualization of the dihedral angle between two intersecting surfaces. So the reason behind I did this was, if a student was in a classroom and we tell them the term dihedral angle, they would not necessarily understand what it means from, it doesn't explain what it is from the name of it. So what I've done is I've just 3D printed off a sample roof structure of a gable end connecting to another gable end with a valley in between them. And I've also printed off a 3D structure to represent what the dihedral angle between two surfaces is. So what I've done now is I have the video uploaded to YouTube. And when I upload it, you can see that I've made this model. And what's being done is I'm just going to represent, we'll say click on, that how you would look at it as a physical resource that you could actually put the dihedral angle into students' hands so that they can further develop. See, I've just decided to represent the dihedral angle between two surfaces by looking at it and interlocking them together. So that's the resource behind why the visualization of the dihedral angle. That's my resource development rationale. So then I went away and I decided that I wanted to try and create an assessment topic relating to all the key principles I've covered within my topic portfolio. So I've covered the topics of orthographic projection, roof pitch angles, auxiliary views, dihedral angles, rebatment and developments of the topic. So what I did was I created this question, a simple enough question, but I wanted to ensure that each section of my key principles was covered. So I created this question around the Tipperary Credit Union within Castletroy on the Plessy Park Road. You might be familiar with it from being in Limerick, but I was told to draw the planned elevation of the roof, determine the dihedral angle between surfaces A and B, but I wanted to use the point view method for this one. But I also wanted to find the dihedral angle between A and C, but I'm using the rebatment method. And then I also want the students to develop the surfaces A and E. So first of all, I created the planned elevation. You have to project your auxiliary view and find the pitch of surfaces A and D, which is given in the question. Surfaces A and D are pitched at 45 degrees. And then we'll find the true height of our object, and we rotate it up into elevation, and we will complete our elevation. And then as a result of completing our elevation, we can bring all them points back down into plan, giving us our completed planned elevation of part A. Part B then, we're told to find the dihedral angle between two surfaces, A and B, using the point view method. So what we must do is we're going to use two auxiliary views to project up to find the true length of our line of intersection, and then using that true length of our line of intersection, we can look parallel along that line and see that line of intersection as a point view. So we should all be familiar. This part of the question will be assessing students' ability to understand the dihedral angle. Then what I also included was the dihedral angle between surfaces A and C using rebatment method, because I feel that the rebatment method is an undervalued principle within students in secondary schools and in third level. So what I did was I put emphasis on using this method to ensure that both methods are understood by students. So you use the rebatment method to find the true length of the line, you cut a plane perpendicular to that, and you rotate it back down to lie flat on the ground, and you bring it back down, and our dihedral angle then can be seen between the two surfaces. Finally then, to further emphasize if students' abilities to understand rebatments, I created two parts at the end to develop surfaces A and E. So we're using rebatment method in order to find the true shape of surface A by rotating it as an edge view to lie flat on the ground or parallel to the horizontal plane, bringing it back, and it'll find the true shape of surface A. And same with surface E. What I'm doing is I am rotating it down an edge view in elevation. I'm bringing it straight down into plan, and I'm bringing out the true shape of surface E. So hopefully from watching this video, Killian can have a better understanding as the rationale behind why I created this assessment and the resource behind what I developed in order to help aid with the visualization of the dihedral angle between two intersecting surfaces.